Hi everyone, this video is about arithmetic sequence focusing in finding the sum of n terms of an arithmetic sequence. So for the sum of n terms of an arithmetic sequence, so let me clarify the following. For a sub 1, a sub 2, a sub 3, a sub 4, until a sub n, this or it is called an arithmetic sequence. A sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus and so on until a sub n. This is what we call the arithmetic series. What is arithmetic series? It is the sum of terms of an arithmetic sequence. Though we cannot find the sum of an infinite arithmetic sequence, we can compute for the partial sum, or the S, or the sum of the first n terms of an infinite arithmetic sequence. Let's have the formula. For sum of n terms of an arithmetic sequence, a sub 1, a sub 2, a sub 3, a sub 4 until a sub n, formula 1, if a sub n is given, of course, if you're going to look for the sum, you need to know where it starts and where it ends. So you should know the first until the last term to be added. So if a sub n, which is the last term, is given, use this. S sub n equals n over 2 quantity, the sum of the first and the last term. S sub n is sum of n terms, n is the number of terms, that's how many terms you're going to add. A sub 1, of course, is the first term, and a sub n is the last term. Now for formula 2, what if we don't know the last term, or if it is unknown? Okay, there are two solutions. So you're going to choose one, which is easier for you. You need to find the last term, of course, before proceeding to getting the sum. And for formula 1, S sub n equals n over 2, quantity the sum of a sub 1 and a sub n. So we're going to substitute the formula for a sub n, or the last term. Therefore, we have S sub n equals n over 2 quantity 2 times a sub 1 plus quantity n minus 1 times d, where S sub n is sum of n terms, n is the number of terms, that's how many terms that's to be added, a sub 1 is the first term, and we need the common difference d. Let's have this example 1. Find the sum of the first 600 natural numbers. Before we proceed, what is a natural number or natural numbers? These are whole numbers except 0. Okay, so that's 1, 2, and so on. Okay, let's identify the given. A sub 1 is 1, a sub n is 600, that's 1 to 600, n is 600 items or terms, S of 600, so that's we're going to look for. Our solution, we're going to use formula 1. We know already that the last term is 600. And there are 600 terms to be added. So that is S of 600 equals S or 600 over 2, quantity 1 plus 600. So that's 300 times 601. Therefore, sum of 600 terms is equal to 180,300. Example 2. Find the sum of all multiples of 3 from 12 to 126. So what are the multiples of 3? So 3, 6, 9. So you add 3 to get the next term. So 12 from 12 to 126. So a sub 1 then is 12. And d is 3 because it's multiples of 3. A sub n, which is the last term, 126 is divisible by 3. When you say multiple, it is also equivalent to divisible. And we don't know how many are there from 12 to 126 that are multiples of 3. So we cannot directly get the sum of n terms. Let's find how many terms are to be added. Therefore, we need to solve for n. That's our step 1. N is equal to a sub n minus a sub 1 all over d plus 1. Substituting the given. A sub n, last term, 126. First term, 12. D is 3. Then n is equal to 114 over 3 plus 1. Therefore, n is 39. Step 2, we can now solve for the sum since we know already the value of n, the number of terms to be added. So solve for s sub 39 using formula 1. S of n is equal to n over 2, quantity, the sum of the first and the last term. S of 39 is equal to 39 over 2, quantity 12 plus 126. So that is 39 over 2 times 138, or 138 times 39 divided by 2. S of 39 is equal to 2,691. Example number 3. What is the sum of all positive odd integers between 6 and 36? Okay, so what are odd numbers? The least odd number or positive odd integer is 1. That's 1, 3, 5, 7, and so on. So let's identify what are the given. So odd numbers that are positive between 6 and 36 is, first term is a sub 1, which is 7. D is 2. The last term is 35. And so we don't know how many terms are there that are positive odd numbers between 6 and 36. So we cannot proceed to getting the sum right away. Instead, we're going to have step 1. We're going to look for the number of terms. Solve for n. So using the formula that we use from example 2, substituting the given, a sub n is 35, a sub 1 is 7, d is 2. Therefore, n is 28 over 2 plus 1, which is n is 15. We can now proceed to step 2, solve for s of 15. We have using the formula 1, substituting the given, that's s of 15 equals 15 over 2, quantity, the sum of 7 and 35. S of 15 equals 15 over 2 times 42. Therefore, S of 15 is 315. Number 4. Find the sum of first 100 positive integers that are divisible by 7. The given are, first term is 7, D is 7, N is 100 because we're going to get the sum of the first 100. We don't know what's the last term, which is the 100th term or a sub 100. So we cannot proceed to solve for S of 100. We don't know the last term, so we can use formula 2 as our solution 1. So S of n equals n over 2, quantity 2 times a plus n minus 1 times d. Substituting the given, we have S of 100 equals 100 over 2, quantity 2 times 7 plus 100 minus 1 times 7. Simplifying, we have 100 over 2 is 50, 2 times 4 is 14, 100 minus 1, 99 times 7. So that's 50. Quantity, the sum of 14 and 693. So that's 50 times 6, 707. Therefore, sum of the first 100 terms is equal to 35,350. Okay, let's try solution 2. By using formula or 2 formula. So we know already the given. So let's proceed to the solution using the formula for the last term, a sub n and s sub n. So step 1, solve for a sub n, which is the last term, or the 100th term, or a sub 100. So that's a sub n equals a sub 1 plus quantity n minus 1 times d. A sub 100 equals 7 plus quantity 100 minus 1 times 7. We have 7 plus quantity 99 times 7. Therefore, a sub 100, it is 700. Step 2, we're going to look for the s sub 100 since we know already the last term from step 1. So solve for s sub 100 using formula 1. S of n equals n over 2 quantity, the sum of first and last term. Substituting the given, S of 100 equals 100 over 2 quantity, the sum of 7 and 700. That's 50 times 707. Therefore, S of 100 is equal to 35,350. Example 5. Find the sum of the first 25 of the arithmetic sequence. Okay, given is 10. D is -3. N is 25. A sub 25, and we can directly use formula 2 for our solution 1. So S of 25 equals 25 over 2, quantity 2 times 10, plus quantity 25 minus 1 times -3. We have 25 over 2, quantity 20 plus 24 times negative 3. That is 25 over 2, quantity 20 plus negative 72. Therefore, 25 over 2 times negative 52 is sum of the first 25 terms of this arithmetic sequence is equal to negative 650. Let's have another solution. So instead of using formula 2, we can have 2 steps using the a sub n or the nth term and the s sub n or formula 1. So we know already the given. Let us proceed to step 1, finding the last term or solve for a sub 25. So using the nth term or a sub n, substituting the given, we have 10 plus quantity 25 minus 1 times negative 3. That is 10 plus quantity 24 times negative 3. Therefore, a sub 25 is negative 62. Step 2, solve for s of 25. So that is s sub n equals n over 2, quantity a sub 1 plus a sub n, that's formula 1. Substituting the given, s sub 25 equals 25 over 2, quantity 10 plus negative 62. That is 25 over 2 times negative 52. Therefore, s sub 25 is negative 650. Example number 6. Find the sum of the first 20 of the arithmetic sequence 3.2, 4.4, 5.6, 6.8, and so on. Given are a sub 1 is 3.2, d is 1.2, n is 20 because we're going to look for the sum of the first 20 terms. However, we don't know the last term, which is a sub 20, and we're going to look for s of sub 20. Solution 1, using formula 2. Substituting the given, s sub 20 equals 20 over 2, quantity 2 times 32 plus quantity 20 minus 1 times 1.2. We have 20 over 2 is 10, 2 times 3.2 is 6.4, 20 minus 1 is 19 times 1.2. So that is s sub 20 equals 10, quantity 6.4 plus 22.8. That is s sub 20 is 10 times 29.2. Therefore, s sub 20 equals 292. Let's have another solution. Okay, for solution 2 in the example 6, we know already the given from solution 1. So let's proceed to step 1. Using the formula for a sub n, let's look for the last term, which is a sub 20. Solve for a sub 20 using the nth term or a sub n. Substitute the given. That is a sub 20 equals 3.2 plus 20 minus 1 times 1.2. That is a sub 20 equals 3.2 plus 19 times 1.2. Therefore, a sub 20 is 26. Proceed to step 2 for a sub 20 using formula 1 in finding the sum. Substitute the given. S sub 20 equals 20 over 2 equals 3.2 plus 26. 20 over 2 is 10. 3.2 plus 26 is 29.2. Therefore, the sum of the first 20 terms is equal to 292. Another example, number 7. Find the sum of the first 15 terms of an arithmetic sequence whose general rule, or the nth term, is a sub n equals 2 minus 7n. The given is the nth term, or the general rule, which is a sub n equals 2 minus 7n. N is 15. S sub 15 is unknown. The first term is also unknown. Now, the last term is also unknown, which is a sub 15. We're going to use the formula for the nth term, which is given, and the S sub n. So step 1, solve for the first term and the last term by using the general rule, or nth term, or a sub n equals 2 minus 7n. A sub 1 equals 2 times 7 times 1, therefore it's negative 5. For the last term, a sub 15, that is 2 minus 7 times 15 is equal to negative 103. Step 2, solve for S sub 15. Using formula 1, substitute the given. We have S sub 15 equals 15 over 2, quantity, the sum of negative 5 and negative 103. We have S sub 15 equals 15 over 2 times negative 108. Therefore, S sub 15 terms is equal to negative 810. Okay, proceed to number 8. This is an application of the key concept of sum of n terms of an arithmetic sequence in real life situation. A theater has 20 seats in the first row, 22 in the second row, increasing by 2 seats per row for a total of 26 rows. How many seats are there in the theater? Okay, let's identify the given. First term is 20 because in the first row there are 20 seats. D is 2 because succeeding rows are increased by 2 seats. Then N is 26 because there are 26 rows inside the theater. What is a sub 26? So how many seats are in the last row, on the 26th row? And then how many seats are there in the theater? So how many seats are there from the first row until the last row, which is 26th row? So solution 1, we can use formula 2 since we don't know the last term. So substituting the given, S sub 26 equals 26 over 2, quantity 2 times 20 plus 26 minus 1 times 2. We have S sub 26 equals 13, quantity 40 plus 25 times 2. That is 13, quantity 40 plus 50. Therefore, S sub 26 is equal to 1,170 seats in the theater. Okay. Let's have another solution for example number 8. Since the first row has 20 seats, and that is the first term is 20, and D is 2 because each succeeding row, the number of seats is increased by 2, and there are 22 rows inside the theater. However, we don't know how many seats are there in the last row, which is a sub 26, and what's the sum of 26 seats in the 26 rows. So we have step 1, solve for a sub 26 by substituting the given in the nth term. We have a sub 26 equals 20 plus 26 minus 1 times 2. A sub 26 therefore is 70. Proceed to step 2, solving for S sub 20 using formula 1, substituting the given S sub 26 equals 26 over 2, quantity, the sum of 20 and 70, we have 26 over 2 times 90, therefore S sub 26 equals 1170. So you've learned another concept related to arithmetic sequence. More videos are available that are related to arithmetic sequence. I hope to see you on my next one. Bye!